thing where I dropped the girls here and we went here and we met and they picked up the van. It was pretty slick. Yeah.
I'm hoping to go hike highlights soon.
Hike what?
Highlight.
Yeah. Well, you gotta wait till there's no snow right now.
No.
Oh, the canyon is down low. The canyon is down low.
No, it's very soon. But that's why I want to go up this soon.
Look out for avalanches. Yeah.
It's a fairly well-established thing.
Yeah. But if you're in a canyon, just be careful, be mindful. Do a little research. Boys and girls. There you go. He's got the answer on his phone there.
I'm going to head out.
Okay. Behave yourself. Don't do anything I wouldn't do.
Oh, yeah.
Stay in touch.
Definitely.
Yeah.
Okay.
Don't do anything I wouldn't do.
I said that.
I know. Class. So you get the wrong answer, guys. You get the wrong answer if you just say cos 57, right? You got to go cos 57 minus cos 0, which is 1. Yes? Okay. Are we good on this? Are we all right? Yeah. Now let's do the direction. Let's do the direction. In this case, if we go from there to there, are we increasing or decreasing the flux and why?
Decreasing.
We're decreasing the flux because cosine of 57 is smaller than cosine of 0. One reason, but a better reason, at least in my head, is that when I angle this thing, there are fewer dots going through my loop. Yes? Fewer dots going through my loop, therefore there's less flux. Really, if you did that, if you counted the dots, you would get something proportional to the flux. Okay? Shh, guys. Okay? So here we go. It's less because there's less light going through the loop. Okay? Now, if we are, so now we got to think about the whole thing, right? We are losing flux, yes? We're losing flux and it's out of the page because of its dots, right? So if we lose it, we replace it. How do you make flux out of the page? Anti-clockwise. That's why it's anti-clockwise.
What's up, Murray?
Physics. What's up, Daniel? I can't believe he said that. The microphone doesn't pick up what they say. So. There we go. Okay. So.
Wait, say it again.
Okay. So we lost flux out of the page.
Okay.
So we replaced it by making it anti-clockwise. Yeah. Okay. Now let's nail down this whole thing about which way the currents flow. Right. Let's review two concepts, and I think this one we know. Right. If we take our thumbs or take our thumb and put it, or I'm sorry, wrap our fingers the way the current goes, our thumb is the direction of, guys, the thumb is the direction of the flux, yes? Inside the loop. Okay? The second thing that we must remember is that if we've got a north and south pole, that the flux lines go out of the north pole into the south pole. Do we remember that?
Yes.
These are important things. So, which way is the flux inside this loop?
Out of the page.
Out of the page. Yeah? In this one, it's into the page. Okay? On this one, if the current's going up the front of the coil, the flux is going to the left inside the coil, right? And here it is up inside the coil, right? Here it is to the right inside the coil. And here it is down. Those are all the possibilities, right? Inside the coil. Okay? Now, let's do some direction of current. In this example, are we gaining or losing flux?
Losing.
We're losing flux, and the reason is that, listen guys, the reason we are losing flux is that it's now in the magnetic field, and when we pull it out, it's not in the magnetic field anymore. Okay? What if I take this thing though and move it around inside here, and any part of it leaves the magnetic field? Am I changing the flux? No, I'm not rotating it. I'm not changing the angle, right? It's just the same thing. I'm not changing the area, and I'm not changing the magnetic field, right? So that does not induce a current, right? It's a steady state. So in this case, we are definitely losing flux out of the page. What do we do? Replace it out of the page, right? By the way, the reason it's a right-hand rule and that they call screws that that move that way, right-hand threads, is that, think about it, if you turn a screw this way, which way does it go? Toward you, yes? And if you turn it this way, which way does the screw go? Away from you. So, when you're working, physicists never, when you're working on the back side of an engine, people always get like confused about which way to tighten or loosen a bolt. Well, can I interrupt, guys? Okay, if I'm on the back side of the engine and I want to loosen a bolt, which way should the bolt go? Away from me, yes? So I know that I need to turn it this way. Isn't that helpful?
Very helpful.
Yeah, if it's a right-handed thread. Now, if you're on a bicycle, remember that the things that hold your pedals on, one is right, one is left. I forgot that once. Okay, yeah. But on an engine, and if I want to tighten it, I need the bolt to go this way. So I'm actually turning it this way, right, to make it go. I actually sit there and use the right-hand rule because it's a real common thing for mechanics to get on the wrong side of the engine and strip a bolt because they think they're loosening it, but they're tightening it, right? Okay, how about this? We're putting it into the magnetic field, so are we gaining or losing? Gaining out of the page. If we gain it, we oppose it. So we go into the page, and it's therefore clockwise. Okay? Okay, here the thing's not moving, but we're changing the magnetic field and increasing it. So are we gaining or losing?
Increasing.
We're gaining it. It's increasing, right? We're gaining into the page. So if we gain it, we oppose it. So we go out of the page. Yeah? X's are into the page, right? Okay. So we gain into the page, we make out of the page. How about this? Same thing, right? We're gaining into the page, so we make out of the page. The X's are into the page, we're gaining it because we're putting it in there, right? How about this? We rotate the loop. Did we gain or lose? We lost it. There are fewer X's going through the loop. Yes? Okay? And so if we lose it, we replace it. So what was it? It was into the page, wasn't it?
Yeah.
So to replace into the page, we go clockwise to make it into the page. Yeah? Remember, no, we're losing it, so we replace it. It was into the page, so we make it into the page. Yeah? Yeah? So it's clockwise, yeah? Now, interesting thing. I didn't really rotate this, I just changed the area, didn't I? The interesting thing is that this area that you see is exactly calculated by using the cosine of the angle. Isn't that cool? When you do the cosine, that's what you're doing, is you're actually calculating the now exposed area, right? So when they set up solar panels, that's one of the things that figures out the exposed area, right? Okay, do we want that North Pole to move away? No! Always oppose the change. It's always been there. We don't want it moving out of town, right? So how do you make a North Pole want to stick around? Give it a South Pole. So how do we make this guy a South Pole? Yeah, the current is going to flow this way, so this side is a South Pole, right? Hey, don't you want to stick around? I've got a nice South Pole for you. Here's a tax break. Please stay. Don't leave to Walton, right? Okay? Yeah? That's what we do, right? Okay? So yeah, it's going to go up the front, down the back. It's going to go this way. This side will be a South Pole. That's the important thing, right? Okay? Now, how about this? Do we want that South Pole moving into town? No, sir. I don't want one of those things living next to me, right? Okay? One of those South Poles, those guys put their pants on 2 legs at a time, or 3 legs at a time, I hear sometimes, right? Or 4. You know? Okay? So how do you keep a South Pole magnet from moving into town? Make it a South Pole magnet that it's approaching, yeah? So it's going to go, yeah. Now, you always want to oppose the change. Always oppose the change. Now, there is a way to do this with flux. There is a way to do this with flux. Yes? The way to do it with flux is this. Remember, flux is that way into the South Pole, yes? So we are gaining flux to the left. If we gain it, we oppose it and make flux the other way, right? Okay, so here we're gaining flux that way, right? Is that right?
Yeah.
And so, oh wait. And so, wait, no, we oppose it by making flux this way, right? Yeah? Yeah. And that works too. Opposing motion, opposing change in flux works. I messed that one up. Okay, how about here? Do we want that South Pole to move? No! We want the South Pole. It's always been here. We always had a South Pole here, right?
Oppose the change.
How do you know when you want it or don't want it? Okay.
You always oppose the change. So if it goes away, you want it to stay. If it comes, you want it to go away. Okay, so the south pole goes away. How do we keep the south pole there?